Nabucco. She will go on the deep aspects of the data and we'll talk about big open data. Thank you very much.
Thank you. Thank you very much. Thank you, Plasto, for the invitation. It's really a great pleasure to be here and to participate in this spring school. Yeah, I'm gonna talk about data, and I'm gonna talk about also an ongoing project that we have now. It's about an approach towards a goal-oriented data integration, because when we are talking about big data, so we are mainly talking about massive volumes of data. So doing data integration in this context is different from data integration in a conventional context where we have the number of data sources is smaller, the volume of data to be integrated is also smaller. So we are investigating. We are still investigating the problems, and we are thinking about solutions. And I'm going to share these thoughts with you. So I come from a database research group that is our name now is Data Semantic and Services Research Group, because we have expertise on data, mainly on data integration, but also on semantics related aspects like semantic web and linked data, ontology. We worked with ontology for 4 years, and also data integration. Since my master degree, I'm doing data integration, and more recently open data. And open data can also be seen in this scenario of big data. And I'm going to try to show this, because we are discussing here a lot about the sensors and data that come from sensors. But I also want to show that we have a lot of different data, different from sensor data, that we can use. So we can put this open data that is available on the web now, and we can put in this context, and then we're going to have much more data to analyze and to get knowledge and get information. And I am also part of the Data on the Web Best Practices Working Group from W3C. And it's also an interesting work. It's a more generic. When we talk about data on the web, we are talking about open data, but not just about open data. It's how we can put data on the web in a way that consumers can easily use the data. Because we database people, we are used to create data. We have the schema, we have a database management system, we have a controlled world there. We have everything there. No, it's not really controlled, yeah. And we have a data dictionary, we have all the information there. But when we go to the web context, it's different. We don't have a DBMS over there that will control the whole thing. Maybe we won't have information about a schema. We don't know who created the data. It's terrible. It's a mess. So there are a lot of initiatives that tries to help this. Okay, how we can improve the publication of data on the web with this feeling. I want to improve this because the data will be, we will have data consumers for this data. Because it's really nice that we can put data on the web. But if nobody uses, it's useless. So it's important that we have people interested in using the data that we publish on the web. So the idea is this. And now we have 3 researchers. Kev is also included here. The services part came from our cooperation. And we have 6 PhD students and 5 master students working on this area. So I'm gonna I'm going to show some motivation, and I also want to discuss mainly this part here. It is our approach, our ideas for goal-oriented data integration, the current status of our work, and some open issues. So the idea is that we can also identify points of collaboration that we can we can send our students over here, the students over here can come over there. It's really to establish a cooperation. So I tried to put some scenarios here, but we discussed this already. So I'm gonna just explain quickly here. We have the mobility scenario. Kevi talked a lot about this. How we can, for example, have applications for management of traffic lights and intersections. And he was discussing this. Parking space occupants also. We have a project in Recife already. And but this, if we see the resources, when I say resources over there, I'm talking about the data sources. So in this context here, I am mainly interested on the data sources, okay? On how we can get the data. The application is something, it's really important for us because we need to have a problem to solve. What is our problem? And this problem will define our goals that will guide the whole data integration process. But what is really important here is that, that we focus on the different types of data source that we can use in our applications. In this case, we have sensors, but we can also have social media platforms, for example, not just sensors. Like the example that Kevi showed about the weather forecast. So we have people. People are also data providers. So it's really important that if we can see this, we can yesterday one of the talks showed the generic model that tried to, it was an integration of a sensor model with a survey model. So everything is a data producer. A sensor is a data producer, a survey is a data producer, a person can be a data producer as well. So this is our motivation. So this one is the water management scenario also. And we have monitoring systems, we have sensors, again, we can have weather stations, we can have conventional systems that provide information about water. And then we can have applications like leakage monitoring, water demand management. So applications here, we need more. We need problems here. What type of applications it's not so good. We can improve this. We want to improve that. And this is a different context because over here, I'm not talking specifically about sensors, but I'm talking about governmental open data sets or open data sources. You can also imagine decision support systems, for example, for planning and manage the public administration's actions. We have this in all the world now. We have this in England, UK. They are really top in this area of open data. In France, we have the open data portal. I'm going to show. Kevi showed the Recife open data portal. So this is data that is available there and that we can use. I'm not saying that it's going to be easy, but it's there. And we can improve, we can work on this data to get information from them. And we can combine. For example, over here, I'm not talking about combining this data with data from social media or data from sensors. But if we are talking about smart cities, it's really important that if we can see this big picture, if we can imagine, okay, I have information about, for example, about all the companies in a city, and I have information about for example, the water problems in the city, and I want to have, I want to create a new, for example, a new company, something like this. Where will be the best place, the best location to put my company, for example, if considering different aspects for me as a owner of a company. But this is not my expertise. Thinking about this kind of problems is not my expertise. We need to talk with the community. We need to talk with people who have problems, who have real problems to solve. So based on their problems, then we're gonna say, okay, I can give you this data. You can use this data to make your analysis, to make your decisions. So in this scenarios that I called here big data in smart cities, but I'm not sure if in all these cases we really have big data. When we combine really a big number of data sources and a large number of data sources, and if these data sources have massive data, then we're going to have a big data picture. And we know that's not just about the volume, it's about the volume, the velocity, the variety of the data. So if we consider this whole picture, then maybe we can talk about really big data. So in these scenarios, we have several types of data producers and also several types of data consumers. So this is really interesting, and makes this problem different from the data integration problem that we are using, because it's not just the heterogeneity of data producers, but also over here, it's both sides. Now we need to deal with a big volume of data here, but also with a big number of users on the top, and they can also be different. The conventional architecture for I can use this here. The conventional architecture for data integration is something like this. I draw this for more than 10 years, okay? We have the data sources. Here we have, for example, a mediator. I'm also a teacher, so we have a mediator with a global schema here. We have the source schemas. And what we're going to do, we're going to have mappings between the global schema and the source schemas. We're going to have queries over here, a query that comes over here and will be decomposed in queries that go to the data sources. The results come back in the mediator. It's a magic box that delivers the integrated result. That's perfect. Even in this scenario, it's really complex to do this. To do a query decomposition, query reformulation, it's a nice work. So this is the really conventional data integration scenario. But imagine how it's gonna be if I have a big, huge number of data sources here. Do you think it's possible to have a global schema? How I'm gonna build the mappings between this global schema and the source schemas, for example. And over here, I made, oh, I can have applications, but they're all the same, just sending queries, and that's something that's not really complex. In this scenario, it's different. I'm sorry for the, I'm not on the, I was there, I think people didn't see
No,
me.
I mean, as long as they listen,
Okay.
it's okay.
So, in the, both data consumers and data producers, they have specific characteristics, heterogeneity, dynamicity, autonomy, and massive volume. This is the heterogeneity we have over there also. But it's heterogeneity is when we have distributed things, we have heterogeneity most of the times. We can have homogeneous distributed databases, for example. But when we have things that were projected independently, probably we will have heterogeneity problems to solve. And this is the case. In the autonomy we also have over there, because the data sources are autonomous. They exist and they want to participate in a data integration solution. But they can change their schemas, they can change their data. It's they have complete autonomy for this. But again, imagine this when you have a really, really big scale. Massive volume, that's what makes these things more difficult. And the dynamicity also, because they have autonomy also to go to the to enter the system and to leave the system. It's really, we also need to deal with this. This was also a problem over there, but it was easier to handle because we had a few number of data sources. That solution was more specific than this one. And the data can be structured. That's good. That's perfect. That's a nice word. When we can work with structured data, they always have the same schema. It's easy. But in the real world, it's not like this. Even when we deal with structured data, we can have problems. If we have, for example, open data, and we have CSV files, nice. They have a good structure. But when we work with open data, this structure may be unknown. That's a problem. That's why we need best practice to publish data. To say, hey, if you're gonna publish your data, publish your schema together. For us, it's in our system, but for some people, it's not. So when we're gonna use the data, where's the schema? What is the meaning of this column here? Because someone else published that data, we just don't know. And data can be semi-structured, for example, XML data. And we can also have unstructured data. This is a mystery for us. Now we are not dealing with unstructured data. Maybe in the future. Now we are really database people, so we are really here. It's structured and then semi-structured. Unstructured, it's really, we're gonna see. We are just flirting. We're gonna be there. And these are the challenges that we are facing now. High level of heterogeneity, scalability, volatility, continuous change, evolution of data sources, both schemas and data. The process needs to be quick, even if it is not entirely accurate. This is something that we also need to have in mind. To have in mind is that maybe we won't have, it will be uncertain. Maybe it won't be very precise. So it will depend on the application that's gonna use the infrastructure for data integration. If you really need a precision, then you have to tell, I need precision. Or you need to tell what your priorities are. It's precision, it's response time, what you really need. And large volumes of data, of course, large volumes of data and data sources, because we can imagine, okay, I won't have a large number of data sources, but the data source that I have, they are really big. Or I'm gonna have a huge number of data sources with small volumes of data, okay? If we look to the open data sets, they can be really small. But if you have a big number, a large number of these data sets, then you're gonna have a problem to solve. Then, and this is lack of a global schema. This is one of the first things that we were thinking, okay, in this scenario, can I have a global schema? I don't think so. Our first feeling is that it will be really hard to have one global schema. What this global schema represents the integration of the source schemas. It can be obtained from the integration, or it can be can also be defined. You can have a bottom-up approach to define this global schema, integrating this and obtaining this, or you can define this, for example, as a domain ontology. Your global schema could be a domain ontology that will represent all the information that you are planning to integrate. But in this context, it's hard to think about the global schema. Maybe a domain ontology. Maybe we can use this. But we are interested in defining integrated schemas on demand. Depending on the application, depending on the analysis that you want to do, then we're going to have an integrated schema. That's why we were thinking about an incremental approach instead of defining everything in the beginning. We're going to do the data integration in an incremental way. This is similar to what we had like in the pay-as-you-go approach. You do things when you need. You don't need to solve all the mapping problems, the schema problems in advance. You solve when you really need. Then we got this architecture. It's an ongoing architecture, okay? Before coming over here, this part was here, and this is new. And we were discussing this, no, we need this over here. And maybe when we start to have to implement our proof of concepts, maybe we will have some changes. But this is the main ideas about this data integration proposal, the goal-oriented approach. So, as I said, we are considering different types of data sources, not just data sources, conventional databases, relational databases. We have here the Web of Things data source layer. I'm going to explain each layer. Here is the storage layer. It can be a possibility to have to store data and materialized. We can have materialized data that comes from the data sources. We can think in having some integration that will be virtual and some integration that will use materialized data. I'm going to show. Here, this is really important. This is something that it was not not really important for us before, because our world was really a closed world. We knew the sources, we had all the information. But now we need to think about the metadata layer. Metadata now is fundamental. And we have over there the goal-oriented data integration layer. This is the data integration process, the main tasks for data integration. So I'm going to explain each one, and it will be a little bit bigger to see. Okay? And as I said, here we have the data source layer. And the idea is that we have physical sources, hardware, really hardware. And for example, sensors, tablets, mobile phones. And we are thinking here about the web of things. So components that can be that we can access via the through the web. So over here we have these physical components, and over here we have what I call here cyber sources that are that produce data or host information. For example, open data sets, social media platforms, transactional systems. These are the conventional, more conventional data sources. But these are also data producers. So we're going to consider both, but we're going to consider that the web is going to be our infrastructure to access the data. Okay? We can also use here a data bus to collect and mediate data. And the idea is that, okay, if you can have a group of sensors, and they will be the data will be collected together, and they can be accessed through the data bus. I'm gonna detail this a little bit more later. And here I want to talk a little bit more about the open data source. We were talking about sensors. We talked about sensors already. And I want to talk a little bit more about the open data source. These open data sets, this initiative for open data is growing. It started mainly with the government, and the idea of publishing data to empower the citizens and to give transparency and stuff like this, so the citizens could know the things that the government does, and how the finance, the information about the finance, information about the tasks of the government. So the idea is that to make data available in a structured and machine-readable data format. So open data is about publishing data on the web in a machine-readable format. There is a whole discussion about what is machine-readable format. Okay, PDF is a machine-readable format. See, it's not easy. We can extract data from a PDF. It's not easy, but some people, especially from the government, they say, no, I publish my data as open data, and we go there, we have PDF. And he's really sure, no, it's open data. Yeah, in my opinion, I think it should be a really structured format like XML, CSV, RDF, JSON. JSON, it's really CSV. We have a lot of data sets published in CSV. And because of this, there is also another working group from W3C about CSV. They are defining a model for CSV. And it's really similar to relational, but it's CSV, because CSV is tabular, like relational data, but they are defining the whole thing for CSV, mainly because of this this interest on publishing data on the web using CSV. Okay, let's tell people how to do this. That's the idea. People are doing, no matter what they are doing, they are doing. So let's tell them how to do this. So data from government, they are mainly published in open data portals. This data is data that is produced by government or government-controlled entities. When we talk about open, we mean that it's data that can be freely used, reused, and redistributed by anyone. It's really important that open data have a license attached to the data to say, yes, you can use this data, you can distribute. And as I said, data is available for download on open data portals, and they are from diverse subjects. For example, you saw this before. This is the open data portal from Recife. Do you know schema, the platform? This is a platform used to publish open data. This is schema that was customized for the city of Recife. If you go in Brazil, the portal of the federal government also use schema. In most of the cities, we don't have a lot that publish open data. I think we have now around 12 open data portals from cities. In Brazil, it's, yeah, it's a shame. It's a shame, but. And they use this because this is open source, and it's a data catalog. So what you can, this is schema, and over here we have, it's because it's hard to see, data sets. And then when you go over here, you can see all data sets that are available in the portal. And you have a description. It's really interesting, but it's just a data catalog. It doesn't help the publication or the creation of data. It's just, okay, you have the data and you go there and you publish. And Kiev showed a picture about the ecosystem, and there was a platform on the core. We are also thinking about, okay, we need to have services to help people to publish data in a proper way. It's really nice that they can use this, but there are other options. For example, you can use APIs to publish your open data. This is also really good, because then your applications can easily access the data. Schema has some APIs that allows you to access the data through API, but it's really simple. So the idea is that we can use, for example, the REST interface that the colleague was talking about yesterday, everything. And we were also discussing about having open data as a service. That's a good idea. That will help people to publish and to consume the data. And but for now we have this, and it's good. We have something. We have the data. It's not the best, but it's something. Okay. This is the open data portal from France, the federal one, and it's similar over here. You have données. Over here we have the themes here. Culture, société, santé. See, you can search. So, over here, this is very rich. And you have this, and you also have this for cities. The city of Lyon has something like this. I think Paris has something like this. So this is really, it's rich because it's data. I don't know the data, okay? I don't know. I don't know exactly the data format. I don't know the quality of the data. I don't know if the data is updated. I know nothing about that. But, yeah, but it's something. So we need to think about this too, about this information that is there available for us. And there is something else that is the linked open data, because I was showing the governmental open data portals, okay? But there are other open data that is on the web that didn't come from the government. This is the idea of linked open data is related with the semantic web. I think Tim Berners-Lee said this. The semantic web isn't just about putting data on the web. It is about making links so that a person or a machine can explore the web of data. See? It's different. It's the web of data. Now, what we have on the web, we have a lot of documents. We still have this because this was the initial proposal for the web, to publish documents so people could read. But it's not just about this. We can also have really data that machines can process, that we can develop applications that will easily process the data. That's why we're talking about machine-readable data. And to make this real, we need to build this web of data. The web of documents, it's there, but we need to build also a web of data, but in a proper way. It will make our life easier. So, linked data, it's a set of principles that describes, linked data describes recommended best practice for exposing, sharing, and connecting pieces of data, information, and knowledge on the semantic web using URIs and RGF. RGF is the data model for data on the web, to publish data on the semantic web. So the idea, look, here is the link between linked data and open data. And this is very famous, the 5 stars of linked open data. And it's really interesting because the governments, they discuss this a lot. No, I want to be a 5-star. To be a 5-star, you need to publish your data in RDF, and the data should be linked. It's hard to get this. It's not impossible, but it's hard to get this. 2 weeks ago, I was in São Paulo, and over there, they were discussing, it was a workshop with specialists from United Kingdom and from Brazil, and people from the government of São Paulo, and they were discussing how to have open data published according to the 5-star schema. But I think this is it's really good that they think about this. But it's really hard to publish in 3-star. That is no proprietary format. That means use open formats, don't use proprietary formats, and use structured data. For example, CSV. This is good. This is really good. To get over here, it's really nice, but it's hard because we need the vocabularies, we need ontologies, and constructing RGF data. It's different. It's like we have a change for the object-oriented paradigm, and some people couldn't think. Oh, because no, what's for guys? You are you were born on the on the object-oriented paradigm, but for some people, not for me. But for some people, it was different, and we had to change our minds. And creating RDF is also different because we are thinking about graphs, triples. We're gonna have triple stores. We won't have tables anymore. Okay, we can map, but it's different. But doesn't mean that we don't have RDF data. We have, and they are there on the web. You know this cloud? If you click on one of the circles here, you go to the data set. It's interesting data that is there, and we can also use it. Okay? And as I said before, this is just to show the work on the data on the web best practices. I just wanted to show the importance of metadata in this context here. Because, as I said, since we are publishing data and people that will use our data maybe doesn't know us, I need to give all the information, all the necessary information to people understand what I'm publishing. So this is just a draft, okay? If you are interested, you can take a look, but remember it's a draft. The first one, we still have a lot to do over here, and it's really hard. It's really hard to get a consensus on this. What is a best practice, and what are the necessary best practices to publish data on the web? You are really welcome to give comments over here and help us to make a better web of data. Or yeah, doesn't mean that I said a better web of data. Doesn't mean that everything needs to be published in RDF, okay? There is a whole discussion about this. We should tell people to publish RDF? No, just publish in a machine-readable format. If it's gonna be RDF or not, we can't tell. But it's good if we have RDF. Because when we have RDF, we can make connections. And this makes the navigation easier. You can go from one data set to other data set really easy. But this is a long discussion. So, closing and coming back to our architecture, that until now we saw just this part, okay? I was talking about open data to show the importance of existing data sources over here that should be explored also. And the metadata layer. The metadata layer, we have a data source catalog. We're gonna have information about available sources and its schemas when they are available. We can also have information about data source metadata, for example, provenance, quality, versioning information. We are really ambitious on this whole thing. We want to have everything. When we have applications, then we're gonna see, okay, this is possible, this is not possible. And it will help us to, this is the ideal word, the ideal thing. And we can also, we have a vocabulary catalog that stores vocabularies used to describe the data. For example, domain ontologies. We can have over here domain ontologies. We can have existing vocabularies, standard vocabularies that will help the integration process. And we have here the components that will make the interface between the data sources and the users. For example, you have this to register the vocabulary. You have this to register the data sources. And you can also have a component that will monitor the data sources to see if they are available, to see if there was an update on a specific data source. And yeah, but it's really important, and we keep in mind that this thing should scale because of the number of data source. And this is the work that we are doing now. We started with the metadata layer, I'm going to show. And we are making experiments of, we are using MongoDB for the data source catalog. And the first results were terrible. And we make some simulations because we don't have real data sources yet, so we made some simulations, and the first results were a little bit disappointing. But we are improving. We are really, and this is really important because this can't be a limitation for the system. This has to help. This should help. This should help the identification of data source, and should be a problem. The storage layer, we are thinking of having an approach where we can have some virtual data and some materialized data. This is really common in a data integration scenario. We can also have a cache over here. Now I'm talking about data. In the other one, I was talking about the metadata schemas. Here I'm talking about storing the data. Because some data that comes from the data source, this is also, we can think that some data, the real-time data, we can deal with this real-time data as soon as they arrive. We can have, Kevi has a student working on this. He receives the data and he triggers some stuff there. Kevi can explain this better. And the data is treated in the moment that it arrives. But we are also interested on having this data and storing, so we can use it later for further analysis. Okay? But even for data that comes from web data sources, can be interesting to have materialized data also. Because the data source can be unavailable, so we're gonna have a replication. But we need to study this to see, okay, when to materialize, when to have this virtual. And these things can, they are data access points. We're gonna use this to access the data sets. But it's we need to go deeper on this part. And on the top there, we have the data integration layer. So this part here is to provide support for the data integration task. And something that is not here, we are thinking about, okay, I'm gonna extract the data from the data sources here. I'm gonna treat the data. I'm gonna show how we're gonna do this. And in the end, I'm gonna provide data for analysis. So maybe we can provide a real integrated data, or we can provide data that can be combined. We can have both, depending on it, because it's not here, but it's like you have another system that you can plug over here, a data analysis system, data mining tasks over here, something that will use the data that we're going to produce. Okay? So this will help us to define the goal, because goal can maybe define it as a query that integrates data distributed in multiple data sources. It's similar to this. So here we could have a query that will, okay, I want to have information about the name, salary, and projects from a specific employee. Over here, we imagine that we're gonna have more complex goals, more complex analysis. But this can also be seen as a query or not. It was interesting yesterday, in the second talk, Sylvie was talking about the hypothesis. So this could be, the input could be hypothesis, something that they want to test, to investigate. And the idea is that the goal will be dynamically defined according to current user needs. So it's something dynamic. And this is also something that we need to pay attention, because, okay, I'm gonna have just one goal, or I can have several goals at the same time. And I'm gonna have, it's the thing that I was talking before, we have a large number of data producers, but we can also have a large number of data consumers. We're gonna consider this. It's possible to consider that we're gonna have a large number of data consumers with different goals. So maybe we need, if we're gonna do this, maybe we need to try to classify the goals. I don't know. This is something that we were thinking a few weeks ago. So the data integration tasks, here are the main data integration tasks. This is common in the literature of data integration. And the idea now is that these tasks will be performed in an incremental way based on a previous goal. We had to do this before. Over here, we had to do this. Okay? We need to identify the mappings. We need to solve entity resolution and to do data fusion problems, because this is a natural when we have distributed data in this context. Okay? It's just the difference is that now we have big volumes, large volumes of data. And schema matching, I'm going to explain fast the three tasks. Schema matching concerns the identification of correspondence between concepts of different schemas. If I have two relational databases, I have employee and in Portuguese, I will say empregado e funcionário. No, it's the synonym. No, I want the synonym of collaborators and employees. Okay, thank you. And I could say, I have this in one data source and I have this in another data source, and I will have a process that will identify, okay, they are equivalent. This is the schema matching problem. And we have a lot of works on this. It's a old problem, but still is a problem. It's really hard to do, to completely have it's not possible. It's really hard to have this without the human intervention, because we are also talking about semantics. It's so, when we have semantics, it's not easy to do everything without the human intervention. But we have a lot of solutions for this, but we are searching for incremental solutions for schema matching. We know about some solutions for ontology matching. Ontology matching is similar to schema matching, but we are now talking about ontologies. And there are solutions for incremental ontology matching, that is the alignment. And the idea is that it's to get information from the data source catalog and create the correspondences. So it's a process. So the general idea is that we can identify correspondences between schemas of relevant data source. This is also a magic word. Relevant data source related to the current goal. How are we going to do this? It's our magic box. How can I identify that a specific data source is relevant to my goal? The data source have concepts that are relevant to answer my question, but this data source, the data is good. Now I'm talking about data quality. I can also include data quality information on my goal. This will help to identify what is a relevant data source. Okay? This is really interesting. How to identify relevant data source. This is also related to the data selection problem and for answering queries, for example, or for building applications. But over here, the idea is to reduce the scope of the schema matching task based on the current goal, but also on previous results of previous schema matching tasks. Because it's like this. I have a goal, then I need to interpret, to see, maybe to extract information from this goal. Then I have the data source selection. I'm going to do the incremental schema matching. For this, I'm going to look to the correspondence repository to see if I already have some correspondence there that will help my schema matching task. I update the repository, and in the end, I'm going to give as a result the schema correspondences. Okay? I'm sorry for this. Chiave's fault. The next step is the entity resolution. And now I have the schema correspondences. The next step is to solve conflicts on the data itself. The first step is to identify clusters of entities. Okay, over here I try to build a cluster for a person called Ana Carolina. Ana Carolina Brandão Salgado. And these are the different names that we can find. We are talking about, imagine that we are talking about bibliographic data, about papers. So now it's better because now we are more aware of this. But before it was really hard. We could have different names for the same author. Then we need to identify, okay, this bunch of people, this bunch of name here refers to the same person. This is the idea of the entity matching task. Entity matching, entity resolution, we have a lot of names for this. And here, Boa Viagem is the name of a neighborhood in Recife. You can have Boa Viagem, B Viagem, BV, bairro de Boa Viagem. Okay? And this is the name of a street. And this happens really when we have, if we analyze the open data sets from Recife, we find this type of problem over there. So we need to identify, to create clusters to solve this. To create clusters, first we create clusters, then we're gonna solve the conflicts. And again, the general idea is to reduce the problem. In this case, we want to reduce the volume of data to be analyzed. Because we have in mind that our world now, it's really big. And we need to have something that will help us to focus. Okay? So again, when I finished entity matching task, I'm going to store the information in a repository, then I can use it later. This was just to show that we start with the whole set of data sources, then we select some data sources in the previous task, then we select just fragments from these data sources to apply the entity matching task. Okay, we are gonna really do like this. And again, here we have the, this is done already. We need to get the, now we need to fetch instance. We're gonna work on the instance level now. Check the repository, do the entity resolution, update the repository, and in the end, we're gonna have the entity clusters. Okay. Now, see, we are really building the result for our goal. The next step is the data fusion. Imagine here, okay, I see that Bernadette is the same, but Bernadette has different affiliations. And this is true. This is my academic life. I started here, and I changed it to this university. After 2 years, here, 2 years, I came here, 1 year I came here, 4 years, okay. Now I hope to stop over here. And, or not, let's see. So, what is in this case, this is a conflict? Can be, if I want to know the history, it's good. But if I want to have just one affiliation, which one should I choose? What's going to be the criteria to choose this? So this is a data conflict problem that is part of the data fusion task. So data fusion task is to solve this type of conflict. And there are different strategies to solve these problems. You can just ignore and let the user to solve the problem. I think we won't choose this strategy because we don't know exactly who's going to be our user. We are imagining that we're going to have an application on the other side, so we need to be a little bit more smart for this. We can ask for, we can, for example, there is this, it says trust somebody else to either provide the correct value or to solve the conflict. Maybe there was a problem before, there was a similar conflict before that was solved, so you can go there and take the same strategy. Or you can propose a solution. But yeah, this is just a general idea, okay? For each one of these tasks, you have a whole literature. Each one of these tasks is a PhD work, okay? We have PhD students working on each one of these things. And this is we had this, and this is the conflicts that were detected based on the data clusters. We solve the conflicts, we do the data fusion, update the repository, do the data integration, and gives as result the integrated data. So in the end, the idea is that we start with a goal, and we're gonna provide integrated data that fits that goal. And we can do this several times. So this is the main idea behind the incremental approach, the goal-oriented approach. As I said, this is an ongoing project. So we have a lot to investigate. And we have 4 PhD students working on this. And I think 3 master students, yeah. So there is a lot of research to be done. And this is what we did until now. We did something already. We have some results. And we worked on the metadata layer. we have a prototype, the Waldo service, and we have this is the thing that this is the data bus. Remember there that the whole architecture there, it was a data bus. This is the data bus. Over here we have here the data producers, and here we have the data consumers. See, this is the streaming. Yeah, Kevin. This is the streaming part. Kevin has a student working on this part. He captures the data, and he deals with the data on real time. Yeah. And this is the discovery and registry that it has an interface with this service here. This service is the same one that is there in our metadata layer, because this can be used, can be reused in different contexts. It was over here, it was used for dealing with streaming, and over there was used for, in our context, more for the batch part, to have to store the data, to get the data, and to identify the relevant data sources. For example, when we have a specific goal, to allow the registration of data sources, and also the identification of relevant data sources. And for this, he used the sensor web enablement, that is a platform with a lot of things, and specifically he used the sensor ML. Yeah. And this is, I think this is, yeah. See here, Sylvia also talked about this yesterday, that she used this as one of because what they proposed, a combination of several languages or approaches to describe sensors. And one of them is this, the sensor ML here. And maybe we can use, I was talking with her, to use their model, and also to extend the model with, for example, to capture information about web data sources. It was there was a talk yesterday that it was presented a common, it was not common, I think there was another name, generic model to capture sensors and surveys in the metadata level, but also the data level, I think. So here we use this to describe sensors. And this part here, it's focused just on sensors, okay? We didn't investigate another type of data source. I did my whole discourse here talking that we should consider other data source, but until now we are working just with sensors. But we're gonna get there. These are the technologies used for the implementation. This work is done by a PhD student, and I asked him, okay, let's investigate other no SQL models, and let's make more experiments to see how they will behave, how because I think this is really important. The metadata catalog is fundamental. So let's investigate if the solution is really good. So over here, it's just to show what is implemented. It's not implemented yet. We are working on this. And he made some tests. He considered different type of data producers. And he tried to simulate a mobility scenario with bus, taxis, and with consumers. For example, consumer will send requests for these data producers. In fact, as someone, I think he did. It was like you can imagine, like someone is. Do you have Easy Taxi over here? No.
I don't know.
Something similar.
Similar. The taxi reservations.
Yeah. So we could imagine that these taxis are the data producers, and the consumers want to order a taxi. And you will have a lot of consumers sending requests, and the service should handle these requests. So imagine you have 10,000 consumers sending 100 requests, and he was he tried to create a scenario based on information of ways. Yeah, but is it like, no? Yeah?
This tax is like Uber, but for actual taxi.
Yeah, he did a good stuff there. He was it was nice to investigate the solution. And he built different scenarios with different amounts of consumers, different queries. Here is the number of requests. And he did without index just once, and it was enough to know that it was not good. And then he built an index, and he worked at, okay, it's not good enough. Let's work with sub-collections, and let's work with cache. So he is really investigating to see a good option for building this metadata catalog. Well, that's it. And yeah, I have a lot of open issues. I think this is good. Yeah, for the researchers, for the students, and for the collaborations. So the goal definition, what is a goal and how to define it. And my colleague over there says to me, but what do you mean? Why goal? Because I think it's you have a target, you have a, but we can also change the name if it's not really the best choice. And the incremental data integration approach, how to deal with the volume, velocity, and variety of the data, how to achieve efficient storage and information retrieval from heterogeneous data sources. And this is not a new problem, okay? But it becomes more complex because of the scenario. How to reduce I/O costs in big data scenarios. So we also need to investigate more what's happening in the big data scenario, because it's something that is it's there, and we have a lot of new things happening every day. So we need to run. In data sources, data producers, metadata. What are the essential attributes to describe a data source? What type of model we're going to use to describe a data source? Where a data source is a data producer. Can be a sensor, but can also be an open data source. That makes things even more complicated, because they are really, it was like the generic model. I need to have a generic model for these different types of data source. This is the part that I was trying to explain when I said, okay, this is not in the picture. How can we integrate our approach to provide relevant data for existing data analysis and mining solutions? I think this can be really interesting, because we have a lot of work on this area, and we can work over here in providing the data in a way that is good for analysis. And real world applications, real world data. I said to Kiev that we're gonna try to use the data from Sertel and other data source that we have in Recife to and try to create an application. But we don't want to have just the mobility data or the sensor data. We want to integrate with other data sources. And for this, it is important that we go to the society, or to talk with people. What could be interesting and relevant for you? As what Kievi said, it is really important that we can build something that is relevant, that we can work and propose something that's going to be really useful. But it's not easy to see. Sometimes I see the data, but what can we do with this data? And that's it. Thank you very much.
Thank you very much.
Merci.
We have room for 2 questions.
I was prepared to speak less, but I think I was really...
My question is actually, how can I say, very basic, because I don't have that expertise in base, but we talk about materialized data. I have no idea what.
I'm sorry. It's something like this. In this scenario here, okay, the data is stored over here in the data sources. When you do data integration, this is the virtual approach, okay? The data is in the data sources. You submit a query over here. The mediator will decompose this query, and the sub-queries go to the data source. The data from the data source is retrieved here. The mediator integrates and gives the results. Okay? Materialized approach. You don't have a mediator here. You will have a kind of a data warehouse, but not a data warehouse in the analytics sense. Okay, in a multi-dimensional data warehouse. It's more in the sense that it is a warehouse for data. Okay, so what happens? You don't need the query will be submitted over here, but it won't be decomposed. Why? Because the data was recovered from the data sources in advance, and they were integrated and stored in a repository. Because over here, what we have, it's an integrated view. We want to produce integrated views of data. The integrated view can be produced on demand when you receive the data from the data source. This is the virtual approach. Or you can prepare the integrated data, stores in a data warehouse, and queries will be made over here. You don't go to the data sources anymore. You understand? And this is what we call materialized view. It's like in database, you create a view. Normally, the view is virtual, but you can materialize. You can extract the data, create that view, and leave it over there. Both approaches have benefits and problems. The problem of this one is that the data can be out of date, because when you query here, not the data source. If there was an update over here, yeah, this can be.
My question is in the other direction. I would like to know if there is a semantic enrichment of this data.
Can be, yeah, can be. You can have this data can be enriched data, in semantic enriched data. I like. But you can also have ontologies, even in the virtual approach. You can also put semantic over here. But this can also.
Okay. Actually, I was wondering. Thank you for the presentation. It's very nice.
Thank you.
Have the opportunity to see you again.
Yeah, he was my student.
But I was wondering, trying to realize in Recife what the center that our colleague presented before with the Caesar and everything, and what you're doing with the open data research. Because we see in Brazil this delay between what we can do with the data. We already have some kind of information, but what makes the government actually decide to take an approach to bring things together to try to integrate data in order to extract real information from it. So we have this delay between what the government is doing and actually what we can do with the research. And so you have this project that you are trying to address some issues, and we have the problem that we are right now trying to solve with the smart cities problems. And I'd like to know if there's some collaboration between these two research centers, and if what kind of work are you trying to do with the government toward implementing a solution to integrate data all over Brazil, if there's some kind of project in that way, or to understand exactly how the government and you are working to solve this problem, to integrate data. Because there's a lot of problem too. I mean, like the government probably don't want to disclose everything in a portal like that, because there's some problem with safety, privacy, and so on. But I know that there's some interesting things that we can do in terms of decision making for cities right now with the information that we already have, but the government probably does not. It's very specific. It's just, is there any kind of approach to work with the government?
On the federal level, I think there are, because as I said before, we have the federal level, the state level, and the city level. And we have initiatives on the federal level to integrate data, to propose common vocabularies. We have this, we have ontologies produced by the federal people who works for the federal institutes there. But it's really hard to talk about, they talk there about interoperability. Semantic interoperability. They want to have, they had some good initiatives, but it's hard to do this, to have a common way of doing things that will allow us to really integrate data.
One example that was a case of the last elections that they were saying about integrating this plan for safety and a system of intelligence to help a national program to deal with the safety in the country. And the first thing that came to my mind is like, we have data, we're not using it.
Yes.
Where we started. And then he showed like the center in Rio de Janeiro, the intelligence center of the police probably in Rio de Janeiro.
The city, the center of operations from the city.
From the city, yeah. I know some part of the project, and I know that they had a really nice job in terms of like analyzing and integrating data, but it's just real.
Yes.
Is
it's
there
just
any
real.
kind of a talk about like trying to bring this to other states and?
Well, we spoke to a guy that's I forgot the name of his position. It's something new, like chief data officer, something like that. And he said that they use a lot of legal instruments to force public departments to provide data. So he said that going on large scale is complicated. We need to have support of someone to write laws. Like things that make mandatory to publish certain type of data. So he got that because it's a mayor project. The mayor was the one that idealized that center. So he was backed by the mayor and the local deputies that make the laws. So he wanted data from to integrate with I don't know, Secretary of Defense, civil defense, something like that. He wouldn't provide that, but he would create a law that would be general enough to make his data and from other offices.
So there's already something happening in terms of
it's really
to bring this to force data integration, but it still is not really allowing the national. Okay.
No.
There's a lot of effort now. He was mentioning the national
Department of Data Processing, CERPRO. We have some initiatives of the federal layer.
Yeah, layer.
They are not replicating the state or city layer in Brazil because we have the CERTO, it's a federal department responsible for processing data and make the federal data, government data public. So we have more initiatives in the federal government level than the other ones because of this department. There is some researchers and people that care about this specifically.
And about the first question, this thing is also part of the EASY project there.
Yeah.
So it's also integrated there.
There were questions here, but I'm going to share them with you.
Okay.
There's just one comment I wanted to say. There's a nice firm called Data Publica.
Sim.
That's a very nice example of what it is possible to do with open data. So thank you very much.
Thank you.
Thank you, Bernadette. So we are starting again at 14 hours. So have a nice lunch. Before going to the tablet.
Because
you and I have to have lunch separately so that we can come back.
I would think to stay here.
You want to stay? I can stay too.
I would think to stay to. I will visit the only for 8 people.
Yes, and they can join them.
Okay. Do you want to stay here?
You can leave them.
¿Qué es de Bernadette?
Elles ont sur le OneDrive, je vais te partager les liens. Qu'est-ce que la dis-moi parce que je ne sais pas au courant.
C'est que
Elle veut le discours, c'est ça?
au moins une base va sortir.
Ok, je peux préparer. Ok.